Okay, in this video I'm going to show you guys how to solve a polynomial inequality. Now remember, an inequality is like an equation, only it's not going to say equal to, like you see in these two examples. You're going to notice greater than and less than symbols in place of the equal sign. We're going to look at two forms. We're going to start with an example showing factored form, like you see here, and then we're going to move on to the standard form where we're going to have to take a step to factor it. So let's take a look at the factored form. I want to solve this inequality. One thing that is a crucial step to every inequality that you're solving is to make sure that one side of your inequality is equal to 0. So you want to isolate a 0 on one side. That looks like an O. It's a 0. All right, now we do this just a lot like what we do when we have an equal sign here. If we had this equal to 0, we would solve for the zeros of the polynomial, and that means we're going to separate the two factors into their own individual equations. So this one, x plus 2 is 0 if x is negative 2. That's one of our zeros. Over here, we're going to see x minus 1. Now it's squared, so that equals 0, but the square doesn't mean that we need to solve anything fancy. We just recognize this as a multiplicity like we saw in some previous lessons. So that means x is going to equal 1, but we're going to make a note that its multiplicity is 2. Remember, that means that we just had the same factor twice, x minus 1 and x minus 1. We're going to get x equals 1 twice. Once we have the zeros, we want to organize this onto a number line. So I'm going to draw a quick number line, and I'm going to put my two zeros on it. Negative 2 is going to be to the left of 1. So there's the zeros. And I also like to make a little note that it shows that those outputs are 0. So these are my x values, and these are my y values that come out of them, the 0. All right, now I'm going to do a little graph. It's a quick sketch of a graph. And something that can really help me is if I know what the ends look like. So I want to think about a lead term. And we'll practice the way we did this before. Looking at each factor, I'm going to pull the lead term out of those factors. So in this first factor, the lead term is x, which I'll jot down. And in the next factor, the lead term is also x. But this factor has that square on the whole quantity. So I want to make sure to get x and square that one. So that makes my lead term an x cubed. And then I want to think about what the ends of that will look like. So if it was an x cubed, I know that it's going to start down in quadrant 3 and end up here. Now, pulling that same information over to my number line, that means that the ends of this number line also do this. So the graph starts down, and then by the time it gets to the end, it's going to be up to the right end. All right, so as I go through, I want to make a note here that my multiplicity was 2 on that 1. So if I'm thinking graphically, the graph is going to start down here, and it's going to cross through when it hits this 0. But when it hits this 0, it's going to do a bounce and have a little baby parabola right there. And that follows along with my other line. So if I kind of sketch this in without too much care, the graph will look something like that. All right, so all of that is awesome because what it does now is it helps me answer the question, which is, when is this polynomial producing outputs less than or equal to 0? So when I think about that, let me bring this down here. When I think about that, I am looking for, I want positive, no, not positive, back up, less than or equal to 0. So I want negative outputs. I want negative outputs. And so when I look at the graph, where does the graph produce those negative outputs? Well, the beginning of the graph is negative, and the middle of the graph is positive, and then positive again on this side. So my negative outputs are in this interval right here. Now, one last check. I also want 0 because I see this equal to. So I want 0 as well. So I want to include in my answer this 0. I'm going to put a bracket right there. And I also want to include this 0 right here. So when it comes to my answer, anything that's either negative or 0 is part of my answer. So my answer is going to be this. The entire interval that leads up to -2, so from -infinity to -2 with a bracket, because I want to include that 0, and the single point where x is 1. So I'll just write and x equals 1. And that is the solution to that inequality. All right, now let's take a look at the next example. The next one was when we have standard form. And so we're going to have to do a little bit of factoring with this one. Okay, so first step, this is a good illustration of this. First step is to make sure that we have 0, and I would say put 0 on the right side of your equation. So that's going to mean that we're going to need a little bit of algebra to bring these terms over. I'm going to subtract 5x cubed and subtract x squared from both sides of this inequality. I'll line them up with their like terms. All right, so now when we take a look at what we've got 3x to the 4th. This is going to be negative x cubed, and this will be a negative 2x to the 2nd power. But all of this zeroes out, so my other side on the right here is 0, exactly what I wanted. Okay, looking ahead just a little bit, this is really the question that we got to answer in the end. We're going to do it with a process, but our goal here is that we want to figure out what's going to generate greater than 0 or positive outputs. Greater than 0, so positive. And we don't want 0, notice right here. So we won't include anything that gives us a 0. All right, so now our next challenge is how do we get this polynomial in standard form to be in factored form. So our next challenge here is going to be, let's factor this. All right, so let's start with our first step is GCF, greatest common factor. Do we have one? It looks like no number for a coefficient will come out, but there is x's in all of those. In fact, there's an x squared. So x squared is the GCF, and we're just going to pull that out. So let's put x squared, and then in a parenthesis, we'll do 3x squared, and then negative x and the -2. And this is greater than 0. All right, so now I've got the trinomial right here, and that trinomial needs to be factored as well. So let's take a look at that. How would we factor that trinomial? It has a 3 in the first term and a -2. I'm going to be multiplying those out, so I'll do that as scratch work over here. So it's -6 when I take 3 times -2. And then I want to find factors of -6 with the goal that they combine and make a -1. So I'm going to say that 3 and 2, if I make the 3 negative, then I will get a -1 if I add those. So that's my split up. And I'm going to split that x term into -3x and positive 2x. And everything else is going to come down. So bring down the -2. Bring down the 3x squared. And this is going to get a little bit complicated. So, oops, I think it's a good idea to, let's bracket this. And let's bracket it off, all this work we're going to be doing in here. And then it's really easy to do. Don't leave that x squared behind. But we're not going to do anything with it. We just don't want to lose it. We're really focusing right in here. So we've got it split into 4 terms. And now it's time to group those 2 at a time. So put group, group, group in there. All right, so take a look in the groups. What can we pull out? Obviously, here's a 3 in each one and an x. So I'm going to take a 3x out. And what's still in? That's going to leave an x in there. And everything came out here, so we'll put the -1. Then bringing down the plus, take a look at the second group. And pull a 2 out of those. And that leaves an x here with a -1. So as we look at now the 2 sets here, the x -1 appears in both as a factor, and that's one of our factors. And the other factor is the 3x sitting in front of this one, plus the 2 in front of that one. So 3x plus 2. And then make sure you don't leave that guy behind. Bring down the x squared as the other factor. Okay, and oh, by the way, all this is greater than 0. Okay, now this problem is a lot like the last one. We have factored form. We have 0 on the other side. And now it's time to find the zeros of each factor and pay attention to any multiplicity. And there's multiplicity right from the beginning. So x squared is 0 because that's got a square on it. Then this is a x equals 0, but its multiplicity is 2, just like a quadratic. Multiplicity 2. The other factors, they don't have any multiplicities. There's no square, no power on the outside of those parentheses. So x equals 1 would be that one. And this one, let's see, 3x plus 2 equals 0. That's going to give x equal to negative 2 over 3. Now we have the 0, so we're going to just organize this on a number line and see what it would look like in a quick sketch of a graph. So checking the order, negative 2/3 comes first. 0 would be next, and that's multiplicity is 2, and then the 1. And each of those x values produces a 0 as an output. Okay, now remember last time how we used an end model to help us get this sketch graph really easy? The end model here, let's go right back to the beginning. What was our standard form? This is a nice thing. Standard form lead term is 3x to the 4th. So we use this as our end model. We'll use 3x to the 4th here. Think about what do the ends of the 3x to the 4th graph look like. And if I was with you, I'd make you hold up your arms and show me. So do it. And they should be up like this. So this polynomial is going to start up and it's going to end up. It's going to start positive, in other words. And by the time it's all the way done, it's going to be up here in the positives. All right, now this is a crossover point. So I'm going to cross from positive into negative. This is a bounce point. I'm going to do a little parabola there. And this is a cross-through point. So if you want to connect all that up, you've got a graph that looks like that. All right, so looking at the signs is really basically your final step here. Looking at the signs, the graph starts with positive values. It moves into negative values. It stays in negative values. And then it crosses over into positive values again. Now, referring back to our question, we want positive outputs according to this. So I'm going to highlight the intervals that generate positive outputs. And that is this end right here and all the way over here at this end right here. And we do not want 0. And so when we write our answer, we will use soft brackets. And I think we're ready to write our answer. So this answer is back at negative infinity to negative 2/3 on a soft bracket. And we're going to join that up with the interval from 1 to infinity.